So in the session today, in the sessions previously, and in the sessions to come, it is very important that you solve the problems, you do the exercises that we are posing here. In the studio, we have Jnanjyoti and Nandita, who are also doing the problems like you are. Sometimes mistakes are made. That's fine. Making mistakes is an essential part of learning mathematics. You cannot learn mathematics if you do not experiment. And if you experiment, you will make mistakes. So don't be afraid of making mistakes. Experiment. And we will go forward by understanding, making mistakes now and then, understanding what it was, why the mistake was made, and we will go forward by solving problems in a definite sequence. For those teachers who are watching this program, the problem sequence that we have been conducting and which we will conduct today is also going to be available on the website of EBCD Math.org. You can go to the website. On the website, the same problem sequence will be available in text. That problem sequence can be followed with students. And moreover, on the website, there will also be self-assessments. So the students can go to the website. You can solve the problems which are given there, and you can understand, you can confirm whether or not you have understood mathematics. So now we have done the revision. Let us go forward with the sessions which we are going to be doing today, the concepts which we are going to be doing today. And again, need is graph paper, some plain paper, and a scale, a pen, a pencil. I repeat, what you need for the session today is graph paper, plain paper, a scale, if you have it, and a pen and or pencil. Jnanjyoti and Nandita, do you have your graph paper ready?
Yes. Yes.
So the first problem now which you have to do is to make two lengths on your graph paper. You can draw freehand, you don't have to use a scale. Make two lengths, X, sometimes, but the first problem is make two lengths. The first length is 6 and the second length is 3. Please draw 6 and 3 on your graph paper. When you've done it, please show it to me. All of the participants who are sitting with graph paper all over India, please draw on your graph paper 6 and 3. You can draw freehand, okay? So now, both Jnanjyoti and Nandita have drawn 6 and 3, but they also have drawn, they have joined 6 to 3. They have joined and they have done 6 plus 3. This is what I have done. So please look at this and see if this is what you have done. So this is 6 and 3, and below that I have joined them and I get 6 plus 3. I hope all of you have done this. So now let's go to the next problem. You have drawn 6, you have drawn 3. Now draw 3 multiplied by 6. Draw 3 multiplied by 6 on your graph paper. So now let me show you what I have done, and then let's discuss the 3 different things. Okay, this is what I have done for 3 multiplied by 6. I have made a rectangle with one side as 3 and the other side as 6. What Jnanjyoti has done, can you give me the paper? Okay. What Jnanjyoti has done is draw a line of 3 and a line of 6 and put a multiplication sign between them. Okay, and what Nandita has done is she has taken 6 times a length of 3. 1, 2, 3, 4, 5, 6. So, yeah, let me hold this up. Well, let me say here that none of these 3 ways is wrong. But going ahead, we will be using this representation. These are different representations for 3 times 6. What I did was a rectangle representation. What Nandita did was a linear representation, a line taken of 3 taken 6 times. And what Jnanjyoti did was an abstract representation, which was a mix of a diagram and symbols. She took 3 length multiplied by symbol 6 length. Each of these is a different representation. As I said, none of them are wrong, but going ahead, when I ask you to draw 3 times 6, I would request you to make a rectangle, because that is what we are going to be using in the other concepts going ahead. So now, having done this, are we ready for the next problem? The next problem is draw 5 into 9 on your graph paper. Draw 5 times 9. In this way, in the form of a rectangle. Okay? That's the next problem. So all the participants on your graph paper, draw 5 into 9. 5 times 9. 5 centimeters multiplied by 9 centimeters. And Jnanjyoti has shown what she has done. Nandita, can you show what you have done? Right. So I have not drawn it because now we are all on the same page. We are all doing the same thing. But now the next problem is, remember earlier we had joined 6 and 3. We had shown 6 plus 3 is equal to 9. I will just show you that graph again. Remember, we had shown 6 plus 3 is equal to 9 in this way. So now the 9 that you have drawn in your rectangle, divide that 9 into 2 parts by putting a point showing the 6 first part and 3 the second part. Have you done it? Show me. Okay. And now, where you have your point showing the 6, at that point, you draw a vertical line from top to bottom, dividing your rectangle into 2 different parts. Draw a vertical line from top to bottom. And show me what you have done. Right. I will show you what they have done. This is what they have done. The 9 on the top is divided into 6 plus 3 and multiplied by 5. And I have divided, I get a big rectangle and 2 smaller rectangles. The big rectangle, now this is the third problem. Listen carefully. The big rectangle is 5 into 9. That's how you made it. So now write inside here, what is this rectangle and what is this rectangle? Write it using a multiplication sign and using numbers. Write this rectangle and write this rectangle. While you are writing, I am going to write it here. So have you written your rectangles? What is the first rectangle? Navnirmiti?
6 into 5.
6 into 5. And what is the second rectangle?
3 into 5.
3 into 5. Very good. I will just show you what I have written here. Here we have 5 into 6 and 5 into 3. And I've written below the same thing in numbers. The big rectangle, which is 5 into 9, that is equal to 5 into 6 plus 5 into 3. The big rectangle, which is 5 into 9, is 5 into 6 plus 5 into 3. And we know that 5 into 9 is 45. We know that 5 into 6 is 30. We know that 5 into 3 is 15. And we have 45 is equal to 30 plus 15. I hope everybody has done this. And now we are going to our next problem. And this is a place where sometimes mistakes are made. So I want you to listen very carefully. We have written here 5 into 9 is equal to 5 into 6 plus 5 into 3. But we also know that 9 is equal to 6 plus 3. I will write that here. 9 is equal to 6 plus 3. So I want you to write in this expression 5 into 9 is equal to 5 into 6 plus 5 into 3. I want you to replace 9 by 6 plus 3. I will write the same problem here on a white sheet and you can do it. This is an important understanding, very simple. We saw that 5 into 9 is equal to 5 into 6 plus 5 into 3. We saw this earlier. Now here I want you to replace 9 in this equation. I want you to replace 9 by 6 plus 3. And how will you write it? Let us see what Navnirmiti has written. Spotlight. Can we have spotlight? Okay, Nandita, what have you written? Have you replaced 9 by 6 plus 3? Okay, please give me what you have written. Let me look at it closely. Both of you. Right, here you have written 9 is equal to 6 plus 3, Nanjyoti, but you have not yet, in this expression, 5 into 9, you have not yet put 9 equal to 6 plus 3. Okay? Nandita has done it. This is what she has done. She has replaced 9 by 6 plus 3, and I will write it on a piece of paper, and this is what we have to do. We have to replace, put 9 equal to 6 plus 3, and I will write what Nandita has done, which is she has done 5 into 5 into 6 plus 3 is equal to 5 into 6 plus 5 into 3. What Nandita has done is a very important thing. She has introduced a bracket, which means that I have to add this first, what is inside the bracket, and multiply what is inside the bracket by 5. Last time we saw on a calculator, if you remember, if we don't do what is inside the bracket first, we arrive at the wrong answer. So bracket means do that first. And while writing 9 as 6 plus 3, we have to put the bracket. This is a rather important point, and we will be using this as we go ahead. Okay? So now, let me do one more activity. Just let me tell that to you. Earlier we had done 6 plus 3 is equal to 9. Now I am doing 5 plus 2 is equal to 7. But this is a little different from what I had done earlier. How is it different, Nandita? Can you tell us how it is different?
Because in this case, you're taking 7 as the sum. Over here, it was 9.
Here it was 9. Yes, so 9 is different from 7, yes. But also, I have drawn slightly differently. What is different between this and what we had done earlier? What is different between this 9 is equal to 6 plus 3 and this 5 is equal to 7 is equal to 5 plus 2? What is different?
That's horizontal. This is vertical.
Correct. Please say that in the mic. How is this?
You have written 6 plus 3 is equal to 9 in a horizontal way, while you have written 2 plus 5 is equal to 7 in a vertical way.
I have drawn it one horizontally, the other one I have drawn vertically. But of course, as you know, mathematically, they are the same thing. I can draw horizontally, I can draw vertically. But when I add 5 and 2, if I've drawn 5 vertically and 2 vertically, I have to join them vertically. If I've drawn them horizontally, when I add 5 and 2, if I've drawn them both horizontally, or here I have drawn 9 as 6 plus 3, then 6 and 3 have to be joined horizontally. We can't add 2 vertically and 6 horizontally. At least here, we cannot add them. Later on, when we go to class 11 and we learn vectors, there we learn how to add a horizontal vector to a vertical vector. But right here at this stage, we are in class 6, 7, and 8. And here, if we draw horizontally, we have to add horizontally. If we draw vertically, we have to draw vertically. Okay? So now, the next problem is, take a graph paper and draw 7 into 9. Draw 7 into 9. All the participants on your graph paper, draw 7 into 9. Of course, all of you will be drawing a rectangle with one side as 7 and the other side as 9. And that is what Jnanjyoti and Nandita have done. I'm sure all of you have done the same thing on your graph papers. And now I will give you the next problem. In this rectangle, earlier you broke up 9 into 6 plus 3 by putting a point at 6. Now you break up 7 as 5 plus 2. And earlier, as you had drawn a vertical line at the point connecting 6 and 3, since 7 is now drawn vertically, at the point separating 5 and 2, please draw a horizontal line. So now you have one vertical line and one horizontal line, and your rectangle gets divided into parts. Can we see what you have done? Can you show me? That is 5 and 2. But also draw the vertical line at 6 and 3. You have done the horizontal line for 5 and also draw the vertical line at 6 and 3 as you had done earlier. Also draw the vertical line. Okay. And now answer my question. Jnanjyoti, into how many parts have you divided your big rectangle?
4.
4 parts. Nandita, you also have divided your rectangle into 4 parts?
Yes,
And what is the shape of each part?
it's a rectangle.
It's a rectangle. So what you have done is what I have done here on my graph paper. I'm going to show you what I have done in my graph paper. So the 9 is divided into 6 plus 3. The 7 is divided into 5 plus 2. And I've divided 9 into 2 parts, divided 7 into 2 parts, and I draw a vertical line and a horizontal line, and the rectangle gets divided into 4 rectangles. 1, 2, 3, and 4. Now each of these parts is a rectangle. So now my next question, which I want everybody to listen to, write the name of each of these rectangles. I'm going to write the name of one rectangle to show you. I want you to write the names of the other rectangles. I have written the name of the first rectangle as 5 into 6. And you know why I have called this 5 into 6. I'm sure you know it. So in the same way, on your graph paper, write the names of this rectangle here, and this rectangle here. So this is what you have written. This is 5 into 6 plus 5 into 3 plus 2 into 6 plus 2 into 3. So the big rectangle is the sum of 4 rectangles. And now what I have drawn here in the figure, I want to write as an equation using numbers. So I'm going to write the first part of the equation and the equal sign, and you have to write the remaining parts. The first part is, the big triangle is 7 into 9 is equal to 7 into 9. 7 into 9 is equal to, you have to write the other 4 parts of this equation. All the participants write the other 4 parts. 7 into 9 is equal to something plus something plus something. What are those somethings? You have to write those. So, Jyanjyoti, can you tell me what are the 4 parts? What have you written? Tell me on the mic what you have written.
7 into 9 is equal to 2 into 6 plus 5 into 3 plus 5 into 6 plus 2 into 3.
Correct. And Nandita has written also something similar. This is what I have written. 7 into 9 is equal to 5 into 6 plus 5 into 3 plus 5 plus 2 into 6 plus 2 into 3. And now let me write the numbers. Let me write the numbers. Let me do the multiplication. So 7 into 9, as you know, that is equal to 63. And 5 into 6, we know that is equal to 30. 5 into 3 is 15. 2 into 6 is 12. 2 into 3 is 6. So here we have 63 is equal to 30 plus 15 plus 12 plus 6. Okay. Let's check this on the calculator. So please take your calculator and do 5 into 6 plus 5 into 3 just. Okay, do 5 into 6 plus 5 into 3 plus 2 into 6 plus 2 into 3 and what do you get?
63.
63. You get 63 because both of you are working on smart calculators. But if you do this on an ordinary calculator and you do the same thing, you will not get 63. Because the smart calculator knows that you have to keep the multiplication first, addition later. The smart calculator knows what we call as BODMAS. That is what we had discussed last time. The ordinary calculator does not know about BODMAS or about ODMAS. And if you do it on the ordinary calculator, you will get a different answer. Anyway, so now we have done multiplication using rectangles. We know that we can divide a rectangle into 4 parts. If I multiply 9 by 7 or 7 by 9, I get 4 parts. So now let's use this to do the next problem, which is a slightly more difficult problem. It's more difficult because up to now, all our numbers 9, 7, 6, 3, 5, 2, all were single digit numbers. Now we are going to go ahead and we are going to multiply 2-digit numbers. So the next problem that you have to do is take a fresh graph paper and do 12 into 13. On a fresh graph paper, draw 12 into 13. All the participants are requested to draw 12 into 13 on your graph paper. As we go ahead later, we will draw freehand on the back side of the graph paper. And you have to imagine that you are drawing on graph paper. Once we have enough practice with graph paper, we don't need to use graph paper for every diagram. We can use plain paper. And going ahead, we will be using plain paper for drawing the rectangles. And you can imagine that it is graph paper. You don't need to measure very accurately as we go ahead. We just need to keep track of the different parts of the number. So have you done 12 into 13? Nandita, show me what you have done. That's a nice big rectangle. And earlier, we divided 7 into 9 into 4 smaller rectangles by dividing 9 as 6 plus 3 and 7 as 5 plus 2. If I want to multiply 12 and 13, there is a simple way of dividing 12 into 2 parts. How will I divide 12 into 2 parts? The simplest way.
6 into 6.
6 and 6. Yeah, very simple. Another way?
11 plus 1.
11 plus 1. Yes. Also rather simple. I'm using another simple way. I want to write both 12 and 13 in a similar way. If I want to write both 12 and 13 in a similar way in 2 parts, how would I divide 12 and 13?
10 plus 2 and 10 plus 3.
10 plus 2 and 10 plus 3. Yes, that's what I've done. And like earlier, I've drawn a vertical line and a horizontal line. So please divide your larger rectangle into 4 rectangles in this manner by drawing a vertical line and a horizontal line at the point of 10 in both the vertical direction and in the horizontal direction. So now you have the 4 parts. The first part is very easy, the big part. What is that equal to?
10 into 10,
Which is
100.
100, right? And what are the other 3 parts, Jyothi, will you tell us?
3 into 10,
Which is?
30.
Yes.
And 2 into 10,
Which is?
20.
20. And the small one is? The small rectangle at the bottom is what? Smallest?
2 into 3.
Which is?
6.
6. So the big part is 10 into 10, which is 100. Then there are 2 other rectangles, 2 into 10, which is 20, 3 into 10, which is 30, and the small rectangle, which is 2 into 3, which is 6. So please write inside your rectangles the name of the rectangle, the number which represents its area. So the first part is 100, the second part is 20, the third part is 30, and the last part is 6. And further, I can now say that 12 into 13 is the sum of these 4 parts. So it's equal to 100 plus 20 plus 30 plus 6, which is 100, 120, 150 plus 6, 156. So 12 into 13 is 156, 156. So this is a diagram way of doing 2-digit multiplication, and we have multiplied 12 and 13 and got the answer as 156. Please check on your calculator what you get when you multiply 12 multiplied by 13. What do you get?
156.
156. Okay. Now, on your calculator, do the next problem and tell me the answer. And then you have to then draw the rectangles and make the parts. Okay, the next problem is 21 into 13. 21 multiplied by 13. What answer do you get?
273.
273.
3.
21 into 13 is 273. Okay. So if I draw a rectangle, one side will be 13, the other side will be 21. Drawing 21 on your graph paper may be a little difficult. So turn the graph paper over and now draw an imaginary diagram where one rectangle, one side is 21 and the other side is 13. Now use a white paper, which is the back side of the graph paper, and draw a rectangle showing 21 into 13. You can draw it freehand also. You don't need to use a scale. Draw a rectangle freehand showing the multiplication 21 into 13. You don't need to measure it. Just draw it freehand. Does not have to be the right size. And now we know that if I keep the units part separate and the 10 parts separate, the multiplication becomes easy, right? So when we did 12 into 13, we did it as 10 plus 2 into 10 plus 3. So when I'm multiplying 21 and 13, I'll divide 13 as 10 plus 3. How will I divide 21?
10 plus 11.
I want the units part separate.
20 plus 1.
20 plus 1. Okay, so I'll have 13 as 10 plus 3 and 21 as 20 plus 1. Okay, so please just draw two lines, one vertical, one horizontal, showing the division of the rectangle into 4 parts. 21 is 20 plus 1 and 13 is 10 plus 3. And now, what are the 4 parts? What is the biggest first part? What is that equal to?
20 into 10.
Which is? 10 into 10 is 100. 20 into 10 is?
200.
200. Right? So the first part is 200. Very easy. Write that. 200. Now let us write the other parts. So the second rectangle is what? 3 into?
20.
3 into 20. What is 3 into 20?
120. 60. 60.
60. Very good. Write that. 60. And what is the third rectangle?
1 into 10 is equal to 10.
1 into 10
is equal to 10. And 3 into 1 is equal to 3.
Okay, write that. 10. And the last part is 3. So you have 4 parts. One part is 200. One part is 60. One part is 10. And one part is 3. So what is 200 plus 60?
260.
260 plus 10?
270.
270 plus 3?
273.
273, which is what we got earlier. When we multiplied on the calculator, we got 273. So now also we get 273, which is 200 plus 60 plus 10 plus 3. Okay, so now what you have done there by drawing very big rectangles, as I said, you don't need to draw very big rectangles when you're doing it on paper. You can now draw a representation. You can draw something which shows the parts. They don't have to measure very accurately. So this is what I have drawn. Of course, you will say that it's not a very good drawing. I will tell you what is not so good about it. This is what I have drawn. This is 21 on top, this line here, into 13. You divided it into 2 parts, 20 plus 1. I divided it in the first line into 3 parts, as 10 plus 10 plus 1, using the same thing about keeping the tens separate and the units separate. And here I divided this into 10 plus 3. Now you may say that your 3 and your 1 don't match. In fact, in your diagram, your 1 is bigger than your 3. Very valid criticism. But I'm not looking at the measurements. I'm looking only at the numbers. Okay, I'm using this only as a guide. So let's forget about the actual lengths. So this is 10 plus 10 plus 1 into 10 plus 3. So this first one should be a square. It's not a square, it looks like a rectangle, but never mind. This is 10 into 10, 100 plus 100 plus 10, 1 into 10, plus 3 into 10, 30, plus 3 into 10, 30, plus 1 into 3, which is 3. So I'll write down the numbers inside there. You can write the numbers in your graph. I will write these numbers as 100 plus 100 plus 10 plus 30 plus 30 plus 3. And this, of course, is 100 plus 100, 200 plus 30 plus 30, 260 plus 10, 270 plus 3, 273. So now we know how to multiply 2-digit numbers using a diagram and breaking it into parts. So now are we ready to go to a more difficult problem, a more challenging problem? Now I'm going to give you a problem where you have to multiply a 3-digit number with a 2-digit number. So what you have to do now is to multiply 13 multiplied by 123. The problem is, I'll write it down here. The problem is to multiply 13 into 123. Now, of course, I can't draw this in centimeters accurately. 13 centimeters I can put on graph paper. But if I want to put 123 centimeters, my graph paper will have to be this big. Because 123 centimeters is 1 meter plus 20 centimeters plus 3 centimeters. So I'm not doing that. I'm going to draw a diagram which shows this. So I'll divide 13 as into how many parts?
10 into 3.
13. 10 and 3, right? I will divide 123 into how many parts, Nandita?
3.
3 parts.
100 plus 20 plus 3.
100 plus 20 plus 3, right? So now can you draw a diagram showing 13 into 123? Can you draw a rectangle showing that? I have also drawn it here, but I will show that to you later. Let us see what Nandita has done. Okay. Actually, when drawing these diagrams, we shouldn't use graph paper. We should use white paper. So can I request you to please use white paper? Never mind, what you have drawn, you can show it. Have you drawn the rectangle? Okay. Very good. And this is what I have done, which is similar to what you have done. I have divided 123 into 100 plus 20 plus 3. And I have divided 13 into 10 plus 3. So I've got now 6 rectangles inside. 1, 2, 3, 4, 5, 6. Can I write each rectangle, the value of each rectangle, the area of each rectangle? For that you must know what is 100 into 10. What is 100 into 10?
1000.
1000, right? What is 20 into 10?
200. 200.
200, very good. What is 10 into 3?
30.
30. What is 3 into 100?
300.
What is 3 into 20?
60.
And what is 3 into 3?
9.
Yeah, so please write all the parts. Have you written all the parts? So the first part, the biggest part is
1000.
1000. Then how many hundreds do you have?
1.
No, hundreds. Just look at the other parts. One part is 200 and one part is
300.
300. How much is that together?
500.
500. So you've got 1000 and here 500. Then you have 30 and 60. How much is that together?
90.
90. And then you have
9.
9. So let's add all the parts. 1000 plus 500 plus 90 plus 9. How much is that? 1000 plus 500 is?
1500.
1500. Plus 90?
Mm,
1500 plus 90?
1140.
500 plus 90. Not 50 plus 90. 50 plus 90 is 40. 140. We are not adding 50 plus 90. We are adding 500 plus 90. So 500 plus 10 is? You have
60.
500 rupees plus 10 rupees. How much is it?
510.
510. 500 rupees plus 50 rupees. How much is it?
550.
550. 500 rupees plus 90 rupees. How much is it? 500?
590.
590. Correct? Plus 9 rupees. So 590 plus 9 rupees is?
599.
Very good. Right? So we have 1000 rupees plus 500 rupees, that's 1500, plus 90, which is 1590, plus 9, so that is
1599.
1599. Okay. So now on your calculator, check what you get when you multiply 123 and 13. on the calculator, check what you get when you multiply 123 and 13. What do you get?
1599.
1599. Okay, so if you don't have a calculator and you want to quickly do a problem in multiplication, of course, the quickest way is the calculator. If you don't have a calculator, then another easy way is to draw rectangles. Okay. In your homework problems and in the website, there will be more problems like this. Here we are not doing these problems because we will just do one or two problems of each type. Let's just see what we have done. We started out by doing multiplication. We multiplied 5 into 9. We multiplied 7 into 9. We broke up 9 into two parts, 6 plus 3. We saw that the big rectangle gets broken up into two smaller rectangles. Then we did 7 into 9. We divided 9 into two parts, 6 plus 3, and 7 into 5 plus 2. We drew a horizontal line and a vertical line. We divided the rectangle into 4 parts. And we saw that the big rectangle is the sum of the 4 smaller parts. Then, having done that, we went to 2-digit multiplication. And the first example that we did was 12 multiplied by 13. Again, we drew a rectangle and we divided that into 4 parts. We chose the parts in a simple way. We divided 13 as 10 plus 3. We divided 12 as 10 plus 2. And we found out that when we do this, the multiplication becomes very easy, because multiplication by 10 is very easy. 10 times 10 is 100, 2 times 10 is 20, 3 times 10 is 30, 2 times 3 is 6, and when we put the 4 parts together, we get 100 plus 20 plus 30 plus 6, which is 156. Having done this, we did 21 into 13. Here again, we divided into parts. We divided 21 as 20 plus 1, or 10 plus 10 plus 1. We divided 13 as 10 plus 3. We did the multiplication and we got the answer as 273. And having built up our confidence with 2-digit multiplication, we went on to do 3-digit multiplication. And for doing 3-digit multiplication, we divided 123 into 3 parts. 100 plus 20 plus 3. 13 into 2 parts, 10 plus 3. And we got the answer as 1599. Now to go further, having done all this, having understood about multiplication by rectangles, I am now going to a slightly different activity, which may seem a little difficult to begin with, but it's not difficult. As I told you, algebra is a very, very easy subject. And what I'm doing now is also easy. It's a little different. It may not be there in your NCERT textbook. It may not be there in the state board textbook, but it is actually rather easy, and it will make things very much easier as we go ahead. And so what we are doing now is not in your textbook perhaps, but we are doing it. What we are going to do now is, instead of writing 10 as 1 and 0, I'm going to write 10 as t. Okay? So if 10 is 3 is t, then what is 13?
T plus 3.
T plus 3. Very good. Nanjoti, what is 12?
T plus 2.
T plus 2. Very good. Okay. Next problem. Now we are going to a different language of writing 2-digit numbers and 3-digit numbers. This is the language of T. We are using T language. My next question to everybody is, we know how to write 13 as T plus 3. We know how to write 12 as T plus 2. How will you write 21? My next question is, in T language, how will you write 21? Think about it and tell me the answer.
2 into T plus 1.
2 into T plus 1, right? But we saw that 2 into x, we could write it also as 2x, right? 2 into x was x plus x. We could write it as 2 into x. But we don't need to write the multiplication sign every time. We can also write it as 2x, which means x plus x. So we can write 21 as 2t plus 1. Okay? Very good. So the first part of the problem has been done correctly. I will just write down a piece of paper what we have just discussed. What we have discussed is that 21 can be written as 2t plus 1. Agree? Now I'm going to write some numbers, and you have to tell me the number in T language. Okay? The number 36. How will I say this in T language, Ganjoti?
3t plus 6.
3t plus 6. Very good. So I think we've done enough examples of 2-digit numbers. Are we ready to go to 3-digit numbers? But to go to 3-digit numbers, we have to know how to write 100 in T language. We have to know to write 100 in T language. So my next problem to everybody, think about it. Using T, how will I write 100 in T language? Any ideas? And here's the hint, something that you have done earlier. I'm going to show you the diagram, and by looking at the diagram, you may understand. Remember, this is something that we did earlier. So now, looking at this diagram, can you tell me how 100 in T language?
T into 10.
T into 10. But 10 is also T.
T into T.
T into T. Right? Very good. So you have discovered how to write 100 in T language. It is just T into T. So now, take a piece of paper, a white piece of paper. Now you don't have to draw everything accurately because we know how to use white paper now for drawing rectangles. So take a white sheet of paper and again draw your rectangle showing 12 into 13. But this time, don't write 10. Wherever you have 10, write T. And let us see what you write. Do the same thing which you have done earlier, but don't write 10. Wherever you have 10, write T. So now I am going to write it here while Jnanjyoti and Nandita are doing their thing. I'm sure all the participants are drawing 12 into 13 as a rectangle, but now without using the number 10. Wherever 10 is there, you're using T. So please draw that rectangle. Now we are doing the same thing what we have done earlier, but we have changed the language. Instead of 10, we are writing T. As I mentioned earlier, and I repeat that, for understanding mathematics, it is very important that you solve the problem yourself. If you solve the problems yourself in all these sessions, I guarantee you, we guarantee you, that you will understand mathematics and you will be able to solve more difficult problems when you go to class 9, class 10, class 11, and class 12. You will be very comfortable working with formula, but not if you just listen to this program as a lecture or view it like a TV program. This is not a lecture, this is not a demonstration. This is a problem session where here Jnanjyoti and Nandita are solving the problems, and all over the country, hundreds of you are solving the problems yourself. Solving the problem yourself is essential for learning mathematics. So please solve the problem yourself. If you have some difficulty, later on you can take the help of your teachers, of your older brothers or sisters. But solving the problem yourself is very important to learn mathematics. And the second thing which I mentioned earlier, equally important. What was the first thing? Solving the problem yourself. The second thing, which is equally important, is don't worry about making mistakes. To learn mathematics, you have to do it yourself, and you have to make mistakes. You have to make many mistakes. And then, while making mistakes, while correcting those mistakes, you understand the problem, the subject more deeply. So don't be worried about making mistakes. Making mistakes is one of the surest and the quickest ways of learning mathematics. So now, while I was just recapitulating some remarks made earlier. I think Jyoti and Nandita have done something on their sheets. So can you show what you have done? You have written 13 as t plus 3 and t plus 2, right? And now that's correct. That is the first part. Now you have to write inside the rectangle the area, but again using only T language and single digit numbers. Now one thing you know very definitely is that small rectangle is 2 into 3, which is 6. You can write that as 6. The small rectangle, that is just 2 into 3, which is 6. That you can write as 6. But what about the other rectangles? How will you write that? You have written that as t into t, right? And the other one is 3 into t and 2 into t and 6. So t into t we can call t squared. So please write t into t as t squared. And 3 into t we can call 3t. And 2 into t we can call 2t, right? So now right below that addition, which is this plus this plus this plus this, write that here using the language of t. So this term here is called
T into T.
Now we're going to call it t squared. So call this t squared, write that t squared plus 2t plus 3t is
5T.
plus 5t, and the small rectangle down is 6. So what you have is t squared, 2t, 3t, 6, and here I write t squared plus 5t plus 6. T squared plus 5t plus 6, right? This is what we have drawn, and this is what we have written. But we know what is the answer of 12 into 13 in numbers. What is the answer? When you did it on the calculator, 12 into 13, what answer did you get? Remember? Do it on the calculator. Get your answer. If you don't remember, get it.
One 156.
156. Remember, we have just done that earlier. We got the answer is 156. Now this t squared earlier, I can write it as 1t squared. So let me write it as 1t squared. 5t is 5 into t, and 6 is just 6. So here I have 156, which I have written as 1t squared plus 5t plus 6. So I can write numbers in t language. Are you ready for the next problem? The next problem is write 175 in t language. Have you written this? T squared plus 7t plus 5. Okay. Now let's write what we had done earlier, also in T language. Remember, we had multiplied 21 by 13, and what answer did we get?
156.
21 by 13. We had multiplied 21 by 13. Remember, we got, do it on your calculator. Just recall what we had done earlier. 21 multiplied by 13.
$273.
273. So can you write 273 in T language? Yeah, I'll come to that. How did you get 273? What did you write down, Jyoti? Can you say that to the mic?
2t plus 7t plus 3.
The first term is 200. So that is 2.
T.
2t is not 200. What is 100? Remember, 100 is
T.
T is 10. Just look back at your notes, what you had done earlier. 100 is T into T. So T into T is, we call that as
2t.
X into X is not 2x. 2x is X plus X. X into X is, recall that. Let's do a revision. The area of a rectangle is length into breadth. If the length is X and the breadth is Y, then the area is
X into y.
X into Y. In a square, the length is X and the breadth is also X. So the area is
X into x.
X into X, not 2X. So X into X is called X squared. So T into T is
T. T square.
T squared. T is different and T squared is different. Yeah, just keep that in mind.
Sir, can't we write T as H for 100 to reduce confusion?
Question by Nandita is, can't we write 100 as H to reduce the confusion? We can write 100 as H, but it is easier as we go ahead to write only in terms of T, because after we go ahead and we reach 1000, we'll have to write 1000 as, we can't write it as H. So we will write it as TH. And then we go ahead and we reach lakhs. So we can't write lakhs as H or TH. We will have to write 10,000. We'll have to write it as, every time we reach a new digit, we have to add a new number if we keep changing the name when we go from 2 digits to 3 digits or 3 digits to 4 digits. But if we use T language, then using only T, I can go from 2 digits to 3 digits. I can write 100 as T into T or t squared. Right? So 200 is
2t square.
2t squared. So how do we write 273?
2t square plus 7t plus 3.
2t squared plus 7t plus 3. Very correctly. There is a question which has come in the chat, which is, can we write 170 as 17t? Yes, you can. It's not wrong. It is correct. It is a different way of writing 170. You can write 170 as t squared plus 7t. You can also write it as 17 times t. I can have 170 rupees by having 17 10 rupee notes. I can also have 170 rupees by having 100 rupee note and 7 10 rupee notes. It's correct. It's not wrong. Okay, that is the answer to the question raised by one of the friends who is watching this on the Zoom network. Now, we have reached the end of our time, but before concluding, I will give a problem here and a homework problem. The problem here is I write 100 as t into t. That is t squared. So my next question is, and this is the problem that you have to solve here. We saw that t into t is equal to 100, which I can also write as t squared. My next problem here, which you have to solve here, is what is t into t into t? Navnirmiti, because Nandita, you had answered this problem earlier. So I'm going to ask the problem to Navnirmiti.
3t square.
This is 3t squared. 3t squared, let me write that. Okay? 3t squared is t squared plus t squared plus t squared. Okay? So this is what is 3t squared. This is what is 3t squared. But my question is, what is t into t into t? So take your calculator and find out what is t into t into t. You know what t is what?
1. 100.
T.
10.
10. So do t into t into t on your calculator. Everybody watching, please do t into t into t on your calculator. What answer did you get?
$1,000.
1000. Okay, because t into t is 100. Again multiplied by t is 100 multiplied by t. So 100 multiplied by 10 is
1,000.
1000. So t into t is actually 1000. And I can write, if I write t into t as t squared, I can write t into t into t as t to the power of 3, t cubed. T cubed means t into t into t, which is 1000. Now notice, how many zeros do I have here?
1,000.
How many zeros?
3.
3. How many times have I multiplied t by itself?
3.
3. How many zeros do I have here?
2.
How many times have I multiplied t by itself?
2.
So can you tell me the next problem, the answer, Gyan Jyoti? T into t into t into t. How many zeros will I have?
10,000.
10,000. How many zeros?
4.
4 zeros. Very good. So this is the This was the last problem that we did today. Now your homework problem is to write the problem that we did earlier, which is 123 multiplied by 13. Remember, we did the problem 123 multiplied by 13. We did this problem in writing the numbers as 100, 20, and 3. We drew the rectangle. Your homework problem is to write this multiplication in T language. Plus, there are some other problems which will be there on our website very soon. I request you to go to the website and solve those problems there also. So we will adjourn now, and before adjourning, I will mention that please note one thing, especially the teachers. The teachers who are watching this program, please note one thing, that we have not used negative numbers at any point in time in our sessions on algebra, the first session, the second session, and today's session, the third session. We have not used negative numbers. This is the insight of our guru, Professor W. Sawyer. You will not find this in any textbook. In fact, in the textbooks which are written, very early negative numbers are introduced, making things unnecessarily complicated. Unnecessarily complicated. What W. Sawyer says, teach algebra first using only numbers 1, 2, 3, the counting numbers, the positive numbers. And once we understand how to multiply expressions, how to multiply formulas using these positive counting numbers, then we can do negative numbers. So in our next session, which is session number 4 of algebra, we will be doing two things. We will be taking the understanding that we have today of writing numbers as in the language of T, and we will be multiplying formulas. We have come to the brink, we have come to the border of multiplying formulas, but we have run out of time. I was hoping to do it today, but since we have run out of time, we will not do it today. We will begin with that in the next session. And in the next session also, hopefully, we will start discussing negative numbers. So I thank all the participants. Please look at the website ebcdmath.org, where you will find some more guidance, and please do all the problems yourself. I hope you are enjoying doing the problems. We meet again after 1 week. Thank you.